In this video, I have a combination clipper circuit, and I have a 5-volt peak at the input in series with a 1K ohm resistor in series with the parallel combination of diode 1 and diode 2. Now I want you to notice how I have the diodes in the circuit. I have the cathode of diode 1 on the ground side, and I have the cathode of diode 2 on the input side. Now I've got my current flowing through the 1K ohm resistor, and this current is coming from the positive half cycle. The positive half cycle flows through the resistor and it reaches a peak voltage of 4.28 volts. That current flows through the resistor and through diode number 1. It reaches a voltage of 4.28 volts, then goes down to 0 volts. Now at 0 volts, it goes into the crossover distortion right here. The crossover distortion is a result of the fact that it takes a while for the diode to conduct. And that crossover distortion is the reason why there is a voltage difference between the 5-volt peak input and the current going through the diode. That voltage difference is 720 millivolts, and that 720 millivolts is seen across the diode. Now on the output, you see where the voltage has this shape. It rises up, then the corners are kind of rounded off a little bit, then it levels out at a peak voltage of a plus 0.72 volts. Then it goes back down to 0 again. Now the crossover distortion leads you to the negative input. The negative input now flows through diode number 2. Now it's a minus 4.28 volts, which means that you have a 0.720 volts across diode number 2. It's the same voltage difference, which is the difference between the 5-volt peak and 4.28 volts. Minus 5-volt peak and minus 4.28 volts. That voltage difference is a minus 720 millivolts. At the output, the voltage rises, the corners are rounded off, and it levels out at a peak of a minus 0.72 volts. And this brings me to the end of the video. Like and share the video, and thanks for your attention.